Welcome to the seventh video on homework portal. Let me just share you my screen. So this videos, a set of videos are videos meant for preparation for your IBDP, IGCSE, CAE courses, or maybe your JEE mains or whatever it is. And I believe understanding how to solve numericals will definitely help you out in solving the numericals or problems, and would also make you more faster in attempting the questions. So with this, the solutions for this problem, this set of problems, 5 problems, would be available tomorrow at 3:30 p.m. Okay, so let me begin with the new set of problems. I hope my screen has been shared. So in this video, I will be just letting you know about the physics problems, and I will also just provide you a hint or clue as how to solve it. The rest of them, you need to solve it. Don't look at the solutions initially, which will be broadcasted on day after tomorrow, that is tomorrow. And just try your best to see how much you can attempt it. Okay. And 5 MCQs should not take more than 5 minutes. So I don't think it should be difficult for you. Try it out. Okay. Let me move on. The first MCQ tells you the diagram shows an analog meter with a mirror behind the pointer. Okay. What is the main purpose of the mirror? Why should this mirror be used? There's a mirror which is being placed over here. You would have observed this in any of the digital meters, analog meters. So why do we have this mirror? There are 4 options given. I think, okay, if our teachers would have told you already, or maybe even when I am working on the lab, I would have told you, why do you need a mirror? Right? Don't say to look at my face. But anyway, you can think very clearly on the same lines and then answer this. Okay. Next question. An object is released from a stationary hot air balloon at height h above the ground. An identical object is released at height h above the ground from another balloon that is rising at constant speed. So there are 2 balloons. One is a stationary hot air balloon, and the other one is another balloon which is rising at constant speed. Air resistance is negligible. What does not. Remember, there's a not word here. Okay. So most of the time, what we do is we look at what is right. And here we should look at what does not. Okay, increase for the object. Which quantity does not increase? Release from the rising balloon. Is it the distance? Is it the time taken to reach the ground? Is the speed at which it reaches the ground, or its acceleration? So which one will not increase? Remember, will not increase. Okay, so you will get to know once when you read the question once, twice, thrice, you'll definitely get to know what am I talking about. A very easy question. There is no calculations being involved. You just need to think about it and answer. But anyway, while I do the solutions, let me show you through calculations also, like how does it, why, okay, or which parameter does not change during these 2 processes. Right. Now let us move on to the third one. This diagram shows the forces acting on the block resting on an inclined plane. It's an inclined plane, so the forces acting on it have been shown. Remember, resting, which means what? The body is not moving. The angle theta is adjusted. Angle theta is adjusted until the block is just at the point of sliding. Okay, until the point is, and block is just at the point of sliding. It means it does not slide. It is not sliding. It is just standing there. And the moment you increase the angle by a little bit, immediately the object starts sliding. R is the normal force. W is the weight of the block, and F is the maximum frictional force. Now, what is the question? Okay, everything has been done. What else you need to do? What is the maximum coefficient of static friction between the block and the plane? Now, I hope you get the question here. Is asking you about the static friction, maximum coefficient of static friction. I hope you would have learned this. There are basically 3 types of frictions. One is static friction, kinetic friction, then rolling friction, right? So what do you mean by static friction? You know how to distinguish this between a rolling friction or a sliding friction. That also I hope you know. So think about it in detail and then answer it. Okay, not at all tough question, very easy to understand and then answer it. Right, let me move on to the next one. A sun bather is supported in water by a floating sunbed. There's a floating sunbed, which diagram represents the magnitude of the forces acting on the sunbed. Now, this is a sunbed. He is floating in water. There is, what is he asking here? Which diagram represents the magnitudes of the forces acting on the sunbed? There are three arrows being shown over here. One is longer arrow. Here it is shorter. Here it is much more shorter. Now, understand what do these arrows represent, first thing. And secondly, based on these arrows, look at the magnitudes and tell me which one is correct. Okay. So the question is straightforward. You have to reason it based on the vectors which have been given. Okay. The magnitudes here, the length of these arrows will tell you something about the forces. Okay. So you need to think about what does it tell you about the forces. The moment I say forces, I already told you, I've given you one more clue. These are vectors. When I talk about a vector, which means what? A force will have a magnitude and as well as a direction. When direction is given, what does this represent? Magnitude. Now, think about it like which one is an appropriate diagram amongst all of them. Okay. Next. A system that consists of a single spring stores an elastic energy, potential energy, EP. Okay. EP. When a load is added to the spring, another identical spring connected in parallel to the system. So he adds a load to one of the springs. Then he adds two springs together, same identical springs, and attaches the load. The same load is applied across the parallel springs. What is the total elastic potential energy stored in the changing system? What is the total potential energy? Elastic potential energy stored in the change system. What if we change the system? That means what is the potential energy in this system? Now, the clue here is that when you have one spring, the spring constant is K. When you have two springs connected in parallel, then what should be your spring constant? I think we've already done this. So look at it, understand what would be the term. What is the term? The effective spring constant. Make use of it and then apply it and we get the answer directly. Okay. And you already know what is the energy of a spring. Energy of a spring is half kx squared. So what you need to do is you just need to apply what is your effective spring constant and the extension thereby produced. Okay. So look at it and then try to get an answer for it. With this, we come to an end for today's 5 MCQs. Let us see once again tomorrow the solution for these MCQs, but do not wait until the solutions are being published. Do try it yourselves, and if you can, and you can actually put all these answers in the comment box, which would really be helpful for me to understand what kind of errors do you make and which are the problems do you face a problem. And later on, I can take up that particular concept and then explain it into detail. Thank you, friends, for watching this. If you like this video, do share and subscribe to my channel for more updates. Thank you.